Hello, and welcome back. This is a section 2.2, and this is a section about functions. And functions is a special thing that we're going to use in this class throughout the remainder of this course. So we want to define it now. And let's go ahead and just talk about what a function is and kind of give you some real-world examples on how you can apply this idea. So you guys can read through all this, and I'm going to kind of go through all of this in an easier way, more user-friendly way to explain it. But let's go ahead and do this. A function, okay, means that for every x value, there is exactly one y value, okay? One y value. All right, and when I use these words x value and y value, there's a number of words that are associated with an x value. So an x value is the same thing as saying input. Okay, we'll use that word to describe an x value. An input, and then a y value is called an output. Okay. Another word that we would describe for x value would be the word domain. Okay, so if I say the word for domain for x value, that means that for a y value, we would use the word range. Okay, I also know that an x value is what I call an independent variable. And a y value is what we call the dependent variable. All right, you've probably heard that word before, or these words before. Okay, so that's the idea. For every x value, there's exactly one y value. And something was set up here. It says that no two different ordered pairs, x, y, have the same x value. Okay, so there's only going to be one y value, and that is associated with every x value. So let's go over here and let's work on a couple of these problems, these examples. And over here, okay. So it says over here, determine if the following relations are functions, and if so, determine the domain and range. Okay, so I'll kind of talk about what that means. So what I want to do is this. The way that I think about it is I write out my x values. Okay, so x, and those are all going to be my first value here. Okay, x is going to be 0, 1, 3, and 5. Okay, my y values in this case are going to be, I'm going to denote these in red. Okay, 1, 2, 4, and 6. So I've got 1, 2, 4, and 6. Okay, and when I see these, all right, I notice that I only have, all these x values are unique. 0, 1, 3, and 5 don't repeat. And they are associated with exactly one y value, okay? So if I wanted to write this, you first have to, come up with that conclusion and ask that question. Do any x values repeat, okay? And if the answer to that question is no, then you have a function, okay? And they have to be associated with a y value, only one y value. All right, so then I would say yes, we have a function, okay? So that's the first thing. Determine if we have a function. So yes, we do, all right? Now I want to write out my domain, okay? And my domain, I'm going to write it like this. I'm going to put a bracket here, and I'm going to write out that this is the numbers 0, 1, 3, and 5, okay? And those are just specific numbers that we have, okay? Now my range, my y values, I'm going to write the same way, okay? I'm going to put a little bracket here, and I'm going to then write 1, 2, 4, and 6. So 1, 2, 4, and 6, all right? And that's it. That's all I'm doing, okay? So let's take a look at the next one. Okay, in this one, I'm going to write out my x values, and I'm going to label them 2, -5, 5, and 7. So my x values are 2, -5, 5, and 7. Okay, and are these associated? And so none of these, they're all unique. Okay, they don't repeat. I only have one of each. Okay, let's list out my y values, 1, 2, 1, and 2. Now, what might be confusing to you is that the y values do repeat. Okay, so I've got 1, comma 2, 1, and then comma 2. All right, so each of these are associated with one y value. Now, the y values can repeat, but the x values cannot. All right, so yes, this is a function. Okay, so yes, we have a function. Okay, and then, you know, what I want to do is come in here and say, all right, what's my domain? Okay, my domain is my set of x values. So I've got, what was it? 2, negative 5, 2, negative 5, 5, and 7. Okay, and then my range of y values. All right, now this is where it gets a little weird. Okay, my range, because I only have 2 unique numbers, I don't need to repeat them. Okay, I just need to write down that I have the numbers 1. Okay, it happens twice, that's okay. And then 2. Okay, so my set of y values, my range, are the values 1 and 2, close your bracket. All right, and that's it. Okay, now let's take a look over here at something like C. Now I'm going to kind of talk more about what this means when we use words and concepts to talk about what what a function is. All right, so let's go in here and let's take a look at these. All right, now I'm going to talk about my x values. Okay, I have apple, peach, and I have apple again. Okay, so I have this idea where I have an apple, a peach, and an apple. Now, what I notice is that apple shows up twice. This means that it's not a function. So not a function. Okay. Now, if I talk about the y values, which we still need to do, orange, pear, and banana, okay, y values are all unique, and that's okay. We can have that, all right? But it's not a function. Okay, so we've got an orange, we have a pear, and we have a banana. Okay, and because apple is associated with, it shows up here twice, and is associated with 2 different things, that means it's not a function. Okay, and that's the idea. All right, so now let's take a look over here. Now this is like a mapping, okay, of a domain and range. Domain, remember, that means x, okay, which is also the thing as your input, okay, which is also your independent variable. Your range is your y value, which is what we call your output. All right, so all of these words can be used interchangeably, and we need to understand that. Okay, so if I say domain, we need to understand that I'm saying x. If I say, and then I could also say the word input. Okay, the range, is the y value. We're going to say output. Okay, so what I want to do is associate my domain with what the range is. Okay, so I'm going to come up with a bunch of different points here. Okay, now A maps to the number 3. Okay, so I have the point, I'm just going to write these out. I have the point A, comma 3. All right, let's write the next one. B associates with 2. All right, so far so good. All right, all these x values are just with one y value, or all these inputs are mapped to exactly one output. All right, so this is 2. All right, the next x value I have, or input, is my value of C, and that's associated with 1. Okay, so far so good. All right, so C, and that's 1. Okay, so far so good. Now let's take a look at my next one, D. Okay, now this value is associated with not only 4, but it's also associated with 5. So that poses a problem. All right, so D, 4, and then D, comma 5. Okay, because this shows up twice. Okay, it repeats. I have no function. This is not a function. Okay, not a function. All right. So all this stuff is kind of a little weird and different, okay? But so that's where I want to talk about, like, what's the point of a function? Okay, by definition, this is what it means, okay? And we kind of need to understand. We need to understand that, but let's think about something in a different way, okay? So I like to think of computers, okay? So my real-world example is we have computers, all right? And this kind of helps with, all right, well, why are we doing this? Why are we talking about it? Why does it matter? Okay, computers are based off of functions, okay? In the most simplest terms, they're based off of functions. Okay, that idea. And let's think about this for a second. Okay, let's say, for example, you have a Word doc. Okay, and let's think about what happens in a Word doc. Okay, that means that you press buttons. Okay, and then they show up on the screen. Okay. So every time, so let's think, for example, pressing buttons, that is like your X value. Okay, that's your input. All right, and as a result, those letters or symbols show up on the screen. The action that's taken is a Y value. Okay, which is your output. Okay, and that's the idea. All right, so what we do is we say, you know, for example, let's say that you press the C button, okay, on the computer. Okay, that's your X value. All right, now what happens as a result? Okay, then the result is that the C shows up on the screen. Okay, and that is your Y value. All right, so we program computers to do this. You know, and let's think about it. Okay, if you only press the C button, only one thing happens. So the conclusion that you need to draw from this is that, and this little symbol right here, it's used in like higher level math classes. I just think of it as conclusion. Okay, is that you know, if you press the C button, all right, if you press C, then only one thing happens, and only a C pops up. Okay, pops up on screen. All right, so you know, imagine this. Same thing with any sort of electronic. That's the idea. When you press a button, okay, that's your input. That's your X value. What happens as a result is your Y value. Okay, so think about this. Think about your phone. All right, if you have your phone and you decide to, you know, unlock the phone, then what happens is, you know, that whatever action you do to unlock it, whether it's a fingerprint or a code or anything like that, then the phone unlocks and it allows you to navigate through the device. Okay, that's the only thing that happens. All right. Now, if you, let's say you unlock the phone, okay, not only does it start playing Pearl Jam on your Spotify account, but it also calls your mother, and then it starts taking a bunch of pictures of what's on the screen. Okay, so only one thing happens. You know, when you do those kinds of things, only one thing happens. So you don't need to do that. All right, or you don't need to, you know, overcomplicate this. But that's the idea. Okay, so we apply this concept now to you know, what's called a function. Okay, and how we use it in algebra. Okay, so let's do this. Let's take a look over here. Now, in this one, I want to talk about this for a couple of reasons. In this example, it says find the domain for the function f of x is equal to 5x divided by 2x plus 7. Okay, so what you have here is an equation. Okay, this notation here, f of x, is a fancy way of saying y. Okay, and what we want to do is we want to take a look at this function and see, okay, what's the domain? Okay, and another thing I would ask on that is, where do I have x values? Okay, have x values. All right, so now what I have here, you know, I have this equation, f of x is equal to 5x divided by 2x plus 7. This is what I call a rational function. Okay, we're going to talk all about these. But if I wanted to find the domain of this function, what I do is I take my denominator, which is 2x plus 7, and I'm going to set that equal to 0. Okay, and there's a reason why. Okay, I want to find the value that will make this undefined. Okay, and the reason is because you can't divide by 0. Okay, can't divide by 0. All right, And so what I'm doing is I'm finding the value that's going to make this denominator 0. And I do that by setting it equal to 0. So I'm going to go ahead and subtract 7 on both sides, and I get 2x is equal to negative 7. I'm going to divide by 2 on both sides, so I get that x is equal to negative 7 halves, okay? Now this was what makes the denominator 0. All right? And if I make the denominator 0, that means that f of x is undefined. I could plug in any other x value, and it doesn't matter, okay? So what I would do is I would say this, that my domain, okay, for this function is all values of x, all real numbers. So let's say that, all real numbers, except x cannot equal negative 7 halves, okay? So we can talk about our x values in this form by talking about our domain, okay? So we can describe any x value that's happening here, okay? And you'll see more and more on why we do that, okay? But for now, that's the idea. So anytime you see something like this, just set your denominator equal to 0, solve for x. All right, let's talk about what this looks like graphically, okay? So what I have, defining a function graphically, we can look at a graph here and say, okay, for every x, do we have exactly one y? And the way we do that is by the vertical line test. So what you'd want to do is you'd want to take your pencil, okay, and create some sort of line, all right, some sort of vertical line. And what I'm going to do is I'm going to take that line and I'm going to move it all the way across this function. Now, as I move left and right, I should only see one point, one intersection with the graph and my vertical line, okay? And so what I see here is that a is a function, okay? Because that graph, the vertical line only touches that graph once, okay? So it is a function. Now let's take a look at b. So if I take this vertical line and look at this value for b, which is a circle, okay, what I know is if I put it over any point on this graph, what I notice is that it crosses the graph twice, okay? So it has 2 intersection points instead of 1, okay? So this is not a function, okay? And so what we want to do is make sure that we can look at a graph, take your pencil, determine whether we have a function or not. Okay, on this page, I want to talk more about this idea of function notation. Okay, typically we're given equations in 2 variables, x and y, but remember that f of x is just a fancy way of saying y, okay? And so, you know, instead of writing the equation like y equals 5x minus 2, this is a function, okay? In function notation, we would write it as f of x is equal to 5x minus 2. So y is the same thing as f of x, okay? They mean the same thing, all right? So what I want to do over here is kind of talk about, all right, what do we do with these, all right? So in this example, you have a function, and let me zoom in just a little bit, okay? And what we want to do, we have this function, f of x is equal to x squared plus 3x plus 2. And I want to evaluate this function for these following values, okay? So when it says find f of 1, let me show you what it means by that, okay? So if I have the function, I'm going to rewrite it, f of x is equal to x squared plus 3x plus 2. Okay, when I find f of 1, what that means is that I'm plugging 1 in for x, okay? And then we're going to evaluate this. So we get 1 squared, all right, let me put that in parentheses, plus 3 times 1, and then plus 2. Okay, so we can evaluate this. 1 squared is 1 times 1, which is just 1, plus 3 times 1, which is just 3, and then plus 2. All right, so if I do 1 plus 3, that's 4, plus 2 is going to give me 6. All right, so now what I have is this. I have that f of 1 is equal to 6. Now, let's put this into context, okay? What this means is that when x equals 1, y is equal to 6. That's the idea. That's what we need to see when we see something written like this, okay? And if I have this, then really this just translates to the point 1 comma 6, and that's it, all right? But we're looking for this. This is your answer that we're looking for, all right? Let's do part B. Part B says find f of negative 2. So B, let me do that over here, and let me rewrite f of x is equal to x squared plus 3x plus 2. All right, and if I plug in negative 2, so f of negative 2, that means I'm going to plug that in for x. So I've got the quantity negative 2 squared plus 3 times negative 2, and then plus 2. All right, so let's go over here and let's do negative 2 squared. So that what that means is I made sure I put that in parentheses because that means I'm taking negative 2 times negative 2. So let me do that. Negative 2 times negative 2 plus 3 times negative 2 and then plus 2. All right, so negative 2 times negative 2 is really going to give me a positive 4. All right, and then if I take 3 times negative 2, that's going to be negative 6. So I've got a plus negative 6 and then plus 2. All right, and what I like to do here, I like to kind of combine my positive numbers first. Doesn't matter how you do this, as long as you get the right answer. Okay, but I'm going to take 4 plus 2. Now I can do that because I'm adding these numbers. I can reorder them however I want. All right, so I'm going to get 4 plus 2 and then plus negative 6, which is going to give me 6 plus negative 6, which is going to end up giving me 0. Okay, so what I have here is I have f of negative 2 is equal to 0. Again, when x is equal to negative 2, that tells me that my function value, my y value, is equal to 0. Okay, which also translates to the point negative 2 comma 0. All right, let's take a look at the next one, which is C. Now this is where it gets a little weird, okay? And what I want to do is find f of a plus h. So what that means is that I'm just going to plug in a plus h, all right? So bear with me here. All right, let's look at part C. In part C, let me write out my function again. F of x is equal to x squared plus 3x plus 2. All right, and if I were to find f of a plus h, what that means is that I'm going to plug in the quantity a plus h in for my variable, which is x. All right, so I'm going to do this. I'm going to do parentheses, a plus h squared plus 3 times a plus h, and then plus 2. Okay, now we can evaluate this. All right, if I take a plus h, then that really means I'm doing a plus h times a plus h, and then plus 3 times a plus h, and then plus 2. Okay, now what I want to do is I want to FOIL this or multiply it out. And I've got a times a, which is going to give me a squared, h times a, which is plus a times h. Okay, I'll use a times h. A times h again, so a times h, and then plus h times h, which is going to be h squared, okay? Distribute my 3, so that's going to give me 3a plus 3h, and then the lonesome plus 2. All right, so then as a result, what we get is we get a squared. I have 2 of these a times h's, so that means I'm going to put a 2a times h plus h squared plus 3a plus 3h, and then plus 2. Now, all of these are unique terms, okay? I can't combine them, okay? And so that's the thing, all right? This is what I have. This is f of a plus h, all right? So you will be asked to do this. Now, this kind of brings me to an interesting point of like understanding what a function is, all right? Now, what I want to do is just kind of think of something interesting, all right? And just how we do this, okay? So let's do this as another example, and let me do this. Let me say you have your function f of x is equal to x squared plus 3x plus 2, okay? And what I have is I'm going to do this. I'm going to say let's find like f of smiley face, okay? Now what I would do is I would just plug smiley face in for x. So smiley face squared plus 3 times smiley face, and then plus 2, all right? And that's the idea. Now, let's think of something else. Let's say if I did like f of triangle. Okay, that means I'm going to do triangle squared plus 3 times triangle, and then plus 2. All right. So I'm plugging in just those values in for x, and then we evaluate them. Okay. Now, when you plug in other variables, you're going to get something with those variables. If you plug in a number, you're going to get something with a number. All right. So that's the idea. So, we have all these homework problems. I'm not going to do part D. We'll talk about that some other time. But part D, or on this homework, go ahead and make sure you do a lot of these problems. Make sure you do a designated amount from each set that I've told you. And we'll see you soon. Thanks. Talk to you later. Bye.